Yeah, thank you, Dr. Philip, for introducing me. So today I'm going to share one of the work I'm currently working on called Beyond the Text, Understanding How Multimodal Generative AI Impact the Student Learning Software Development. So since the first generation of the ChatGPT was launched in the late 2022, this generative AI tool has transformed how we think and learn about the CS software engineering educations. One of the major benefits is their adaptive support, as this tool can handle a various tasks like explaining the concept, analyzing a complex problem, generating code, and provide instant feedback for the student. Moreover, the AI can also play as diverse roles, like adding a tutor to decompose and explain the problem step by step, or a compiler to help understanding the code, or even a partner to explore and solve the programming task. Essentially, this tool can fundamentally speed up the learning process because the student can seek the help within one platform without the need to switch between browser tabs or finding the information across different sources. So to provide a better experience workflow, generative AI tools are rapidly enhanced and changing the ways we interact and communicate. So thanks to the development of this multimodal large language model, generative AI platforms can now process and respond to a wide range of input, everything from text, image, audio, and video. Therefore, we are actually moving from the old time of the text-only model to a new world where this AI can interpret and create across multiple types of media. For example, back in 2022, we could only ask AI question by typing a long paragraph, and in return, we got a long response. But nowadays, this platform can support many features, such as like uploading the file, generating the image or video through describing a text in text, or communicate via a voice input, or coding using the agent mode, or even support some real-time live stream with the screen sharing. Essentially, communicate with these AI tools is becoming much more immersive for their richer and more intuitive interactions. So how can the software development somehow be related to these multimodal generative AI tools? The answer is that the multidimensional nature of the software development process, where the developer might need to switch between the different contexts. So in the software development lifecycle, it covers multiple phases like requirement analysis, design, implementation, testing, deployment to maintenance. Throughout these phases, developer might need to collaborate and communicate with their teams, visualize a bunch of user interface, debug the issue by logging the errors in the terminal, or navigate through the complex code base, where the generative AI might play a critical role in process their multimodal functionalities. So motivated by this mentioned benefit, and there is a research gap that no work has been done in this field, I proposed a research study to explore how the multimodal generative AI impact the student in learning the software engineering coding task. And essentially, I'm specifically looking into this following research question, RQ1, to see what the prompting strategy and interaction can appear of this student seeking for help. RQ2, to investigate whether the multimodal can improve the task accuracy and efficiency compared to the monomodal interaction. RQ3, to explore how the student perceive and prefer between different modality across the software engineering task. We argue that the multimodal learning can benefit from the learning process for the following theories. So the cognitive law point out that learning can tend to break down when the information become overloaded due to our limited working memory. Besides, the Mayer cognitive theory of multimedia learning shows that we can learn more effectively through an appropriate visual and auditory aid. By using this strategy like cognitive offload during the development process, students can share the problems via the media by saving their memory from describing the problems in the text, or they can use a dual channel processing like looking at the code while hearing the AI explanation to prevent mental overload. So in this work, I designed a between subject study to compare two workflows, multimodal versus the text-only workflows. Specifically, there will be two participant groups to complete the same set of software development tasks using the generative AI tool called Google AI Studio through a think-aloud section. During the user study, the control group will interact with the AI through a text-based interaction only, while the experimental group can access to all the mode like chat, media upload, and the stream real-time like audio and screen sharing features. So the set of the software engineering coding tasks are designed and built based on an open source software project. And the project I select is a lightweight React-based Next.js portfolio web application that primarily using the JavaScript. And based on that, I designed three main tasks. The first one is to add a new feature based on the existing project. And then next one is to write a test case to test one of the functionality of the added feature. And then to localize and fix the error of a buggy feature. As the original project focused on more on UI and content, I modified the project files to extend it with a testing framework, which allow me to write a text case as well as write the text suite to validate the implementation task from the participant. For the study procedure, each study section will be recorded, and before the task distribution, participants will complete a warm-up activity to get themselves familiar with the Google AI Studio interaction mode, and then they will complete a pre-survey to collect their background information, their prior experience with generative AI tools, and overall experience and opinions toward using the generative AI in learning software engineering context. After that, they can start working on each task in a given range of time. A quick task load index will be given to capture their workload after each task. And finally, they will complete an existing survey to capture their engagement or experience and learning impact and any other improvement suggestion of interacting with the generative AI to solve their task. So about the data, we have collected and analyzed three data sources to offer a more comprehensive view of the interaction between the student and the AI. For the behavior logs, we will transcribe and apply the semantic analysis to code their think-aloud script and also categorize their coding patterns from their recordings. We also measure their task performance through the metrics efficiency and accuracy. We will count the time of completion and the number of the line of code for the efficiency comparison, and use the automated text suite and manual review to check the added feature and the buggy feature result. Lastly, we will explore their learning impact, such as the workload and the perception through their self-report from both surveys. So in this study, I will uncover how students tackle the software engineering coding problems via the different mode in the generative AI tool. And throughout this process, I envision that the finding will provide some useful interaction guide on how to integrate this tool in the software engineering curriculum. More practically, this could meaning like updating a teaching method to incorporate the generative AI tool more effectively, like teaching the student how to prompt diverse solution for different modalities. Besides, the result might also provide some design implication for the future generative AI interface that tailor to the software engineering education, such as focus on the interface that can support multiple ways of interacting, like combining the text, voice, or video, and providing a more context-aware feedback to aid the learning process. So here are some potential limitations from this proposed study. The scope of the task cover only the coding phase of the software development lifecycle. Future work can replicate the study across the full development cycle, as well as some other contexts other than the open source software. The finding might not generalize to the student in other curriculum or institution or the context, since we only conduct the study within a single institution and one programming language. Lastly, the data analysis might be subjected to the researcher's interpretation, but we will mitigate this risk through the multi-researchers coding and the iterative refinement in the process, or even using the AI tool for the further validation. And thank you for your listening. One last thing to know, this is an ongoing work. I'm currently recruiting participants right now, and my goal is to collect 25 participants. Each study will be conducted around 90 minutes. We do compensate the participant for attending the study. So if you interested or know any friend who might be available, please feel free to contact me. Thank you for your attention.